Salam sejahtera everyone. Today I would like to introduce a new method, real-time reverse transcription loop-mediated isothermal amplification for rapid detection of SARS-CoV-2. I'm Yiling. The team members include Prof. Sharifah and Dr. Shashila from UMMC, Dr. Timothy William and Joel from Sabah, and Injek Khairi from Celia Tech Holdings Sdn Berhad. I will first start with introduction and objective and then solutions and patent proof of concept, our technology readiness level, and the expected results.
The problem statement. The rapid spread of coronavirus disease 2019 represents a corporate public health threat with a significant global effect on the human healthcare, economic, and many other sectors. In a short time, a few real-time PCR methods have been developed. These methods are highly sensitive with molecular techniques based. However, it is complicated and costly, which hamper its large-scale applications, especially in low-resource testing areas. Loop-mediated amplification, in short LAM, is a very sensitive, easy, and rapid method. This method can be completed in less than 1 hour. In this study, we propose to combine RT-LAMP assay with lateral flow immunoassay for direct visualization detections. Ideally, this can be served as on-site point-of-care tests that can be performed at the bedside. Early diagnosis and adequate initial management are very crucial for better prognosis of COVID-19 because there's no specific treatment. Rapid diagnosis can also prevent the spread of the disease by immediate patient isolation. The next video will give you a brief idea about loop-mediated isothermal amplification assay.
Loop-mediated isothermal amplification assay, in short LAMP, is a rapid and cost-effective molecular diagnostic method. LAMP is highly specific as it employs a total of 6 primers, recognizing 8 distinct sites of a target region. A strand-displacing DNA polymerase called PST polymerase is used for DNA synthesis to bypass the need for 3 temperature cycle conditions as seen in a normal PCR. LAMP can amplify DNA to million copies in less than an hour under a single temperature.
Well, PST polymerase works best between 60 to 65 degrees. To run the LAMP test, a simple incubator that can maintain the temperature at 65 degrees is sufficient to perform the test. A PCR machine is not needed, therefore, it is very affordable. On top of that, the amplification can be completed in less than 1 hour. The clinical sensitivity and specificity of this test has been proven to be equivalent to RT-PCR.
So this leads us to the study objective, and the aim is to develop a rapid, inexpensive, and simple point-of-care test for diagnosis of COVID-19. The objective include to develop and validate the performance of this RT-LAMP assay for detection of SARS-CoV-2 using direct nasopharyngeal swab samples. And then we will demonstrate the performance of this new test in a diagnostic lab and also clinical settings in UMMC and also in hospital in Sabah. Lastly, we will produce a complete SARS-CoV-2 RT-LAMP kit.
So this is a paper published in PeerJ on real-time LAMP assay for detection of SARS-CoV-2. These projects, we collaborate with Hospital Sungai Buloh, with Datuk Dr. Koh and Dr. Kalai, where 47 positive and 42 negative samples were collected and tested on RT-LAMP, and it's shown that RT-LAMP is 100% sensitive and specific for detection of SARS-CoV-2. With these preliminary results, we managed to patent the primers used in this LAMP assay. These slides here will summarize the process of LAMP in the lab and also show our progress so far. First, nasopharyngeal swabs is collected from the patients. It is then added to the LAMP reactions, and this tube can be incubated in a heating box at 65 degrees for 30 to 45 minutes. and the result can be observed in less than 1 hour by looking at the graph forming on the turbidity meters, or by looking at the color changes as I mentioned just now. The negative reaction will remain purple in color and positive reaction will show as blue. This product has been patented. However, perspective of color changes is very subjective to individuals. Thus, our current focus is to develop a LAMP lateral flow device where the LAMP product can be loaded onto a lateral flow device and the result can be observed by looking at the band form on the device. RT-LAMP assay has been successfully developed and tested using clinical samples. For now, we are still testing whether we can use direct nasopharyngeal swabs for this RT-LAMP assay. So the product prototype and technology readiness level for this product now is at TRL4. This flowchart here shows the overall methodology used in these projects. RT-LAMP will be combined with lateral flow and optimized. Then the analytical sensitivity and specificity will be evaluated using RNA transcripts. Once this RT-LAMP lateral flow is ready, it will be used to screen 150 positive and 50 negative COVID samples. The result of RT-LAMP lateral flow will then compare with RT-PCR and RT-LAMP as well. Lastly, the clinical sensitivity and specificity will be calculated. This study has been approved by MREC Committee of Ministry of Health. There are many benefits of these projects. The cost per reaction for RT-PCR in-house test is about 40 ringgit per reactions, and for commercial test kit, it costs about 90 to 150 per reactions. But RT-LAMP lateral flow costs only 22 ringgit. And on top of that, it doesn't require expensive equipment, where a real-time PCR machine can cost about 200,000. RT-LAMP lateral flow is also very fast. It can be completed in less than 1 hour, and it is very easily performed. And it has been shown to be more sensitive compared to RT-PCR as well. So at the end of the project, we are hoping to commercialize this as a test kit. With this, our partners can be beneficial from the sales of the manufactured products or device and benefit from the royalties from the licensing as well. The target audience for the product will be hospital, clinics, Ministry of Health, of course the patients. An inexpensive, rapid, sensitive and specific RT-LAMP assay was successfully designed for SARS-CoV-2 detection. This test will then combine with lateral flow device for direct detections, and optimization is still ongoing to utilize direct NPS samples for testing. We hope that RT-LAMP for SARS-CoV-2 can be adapted to point-of-care diagnosis as supported by previous studies. Thank you for all your attention. This study is supported by Prototype Research Grant Scheme PRGS from the Ministry of Education Malaysia. Before I end my presentation, I would like to share with you a short video about how LAMP is performed in our lab.